Good morning, class, and welcome to this lesson on Kinematics 8 position time graphs. Today, we will be able to describe what is happening physically with different shapes in a position time graph. Okay, so basically, I'm going to give you a graph. We're going to make a line on it or something, and then we will determine what is happening, what's happening with that object. Okay, so before I start, I just want to point out that graphs are very, very important. Graphs, I'm just going to write that down. Graphs are important because in the real world and science world, not necessarily in classroom world, but in science world, we take measurements. We have instruments and we gather data. And most of the times we gather data on graphs. And so being able to gather data and describe what's happening is really the point of science. Can you collect data and describe what's happening? So a position time graph is really a good piece of data to have. And before I even start, we don't have these in our class, but most people, especially in the physics world, will have something called a motion sensor. It looks just like a box, and it has like a screen right here. This is called a motion sensor. It is hooked up to some sort of display, and if you take an object and you move it closer or away from, or back and forth, and all around, this sends off sound waves. This sends off sound waves, hits the object, and based off these sound waves being sent and received, it will actually display on your little display here. It'll display a graph. And so a lot of times when it comes to AP Physics, when it comes to physics questions, they might give a question like, what would you do with a motion sensor? Or here is a motion sensor, and you need to understand, you need to develop a lab, you need to develop a experiment using this piece of equipment. So I just want to point out, because it's a very common AP Physics question, that if you don't have one, if you don't have experience with one, there is something called a motion sensor, and this is what it does. It detects the motion and prints off a graph for you right there, okay? Pretty cool piece of equipment. So that is it. That is a motion sensor. So let's start here. A position time graph is exactly what it sounds like. Okay, it is a graph. Oh, I'll even make it go further, and we have positive x, negative x, and time. We are measuring position and time. Okay, so if we had a straight line on a position time graph, that means an object is standing still. The position is not changing. The position is not changing. You can see by a straight line. So if we call this, positive 3 meters, 3 meters away from our origin, the person is standing there at 3 meters away from the origin, or the ball, or the object, or whatever. If I write it down here, this object is still standing still. It's just standing still at a negative x position. So if I look at like a timeline here, if I call this 0, if I say there's a ball sitting here at 3 meters, and then over here we'll call this negative 2, a ball is sitting here at negative 2 meters. So that's all this is telling you, is that we have an arbitrary point, we call this 0. And so if this ball is 3 meters away from 0, positive 3. If it's over here 2 on the other side, it is now negative 2. Okay, so a straight line means something is standing still. Okay, straight line. Okay, so let's move on. If we have a graph like this, we have this is a straight sloped line. A straight sloped line. So we can see it has a slope here, okay? This is indicative of constant velocity. This is a constant velocity piece of a graph here, because what is velocity? Velocity is change in displacement over the change in time. Velocity is a change in displacement over the change in time. And if you look here, the slope of this line is the rise over the run, or displacement over time. So in this particular instance right here, our change in displacement is 8, our change in time is 2. 8 divided by 2 is 4 meters per second. So the velocity for this object in this graph is 4 meters per second, because the slope of this line is indicative of velocity. So you need to be able to look at a graph and figure that out. Know that because there's going to be other graphs that are not like this where it's going to show you, look, you have one variable here, x, one variable here, t. What's x over t? Oh, x over t is velocity. Well, that slope is the velocity, okay? So a straight slope line is constant velocity. So we can have a similar graph like this. Okay, this is also constant velocity, same thing, but this is constant negative velocity, meaning we are traveling back toward our point of origin. We are traveling back toward our point of origin. So if we had a graph, if we had a graph like this, where we have position and time, and we have, so maybe we're traveling at constant velocity, we stop, and then we travel back. Notice at this point right here, this point right here, this is when we return. This is when we return to the origin. This is when we return to our starting point. Because this 0 right here, this 0 is the origin. This is the starting point. If you want to, I can make that a little simpler. I can just do this. I can just do this if that makes it easier to understand for you. We started off here at the origin. We stopped. We returned. And because this is x equal to 0, x equal to 0 right here, we return back to our origin, okay? So this is a straight line is a constant velocity graph, okay? A straight line is a constant velocity graph. So we can see that right here in this picture. I drew a very similar picture right now. This person was traveling, okay? Stopped, traveling back, okay? Stop, traveling back. Notice the greater the slope, greater slope equals greater velocity. Okay, this person right here was traveling at 2 meters per second. 2 meters per second. You can see here the slope of this line isn't this. The slope isn't as high as this line here. It's a little bit more flat, and so over here the slope here is -1 meters per second. -1 meters per second. The word here is +2. Notice I'm only looking at the magnitude, the number, the magnitude. Okay, I'm not concerned about the direction necessarily, just the magnitude. So greater slope equals greater velocity. Okay, greater slope equals greater velocity. And